Hey, it's Mr. Lum again, and we're going to continue on with some more nomenclature for chemistry, and we're going to be talking about polyatomic ions. So a polyatomic ion is an ion that is made up of more than one atom. Poly means many. Atomic means atom. So it means many atoms and is an ion. Again, an ion just means that it has a positive or negative charge, or in other words, that the protons are not equal to the electrons, which gives it a charge. So here's a few examples of polyatomic ions. Some polyatomic ions are positive, like ammonium. Ammonium is NH4+. It's polyatomic because it has 5 different atoms inside of it, and it's an ion, which we can signify by this charge, positive charge up here. There are some negative polyatomic ions, like acetate, which is made up of CH3COO. It is an ion, and it is a negative ion because we can see that there's a negative sign here. There's a long list of negative ions that we have here, and there's many, many more. So now what we're going to take a look at is how do we name something that contains a polyatomic ion. So there's 3 steps in naming ionic compounds that contain polyatomic ions. The first step is identify the ions in the formula. So let's take this first example right here. We have NaClO3. What we're going to do is we're going to identify all the ions. We have Na. Here it is right here. So I've taken a piece of the periodic table so we can use it as reference. And I've also taken a piece from our polyatomic ion sheet to use it also as a reference. Then what we find here is we find ClO3- right here. Okay. You can also find Cl or chlorine and oxygen on your periodic table. However, this section that I underline in blue is a polyatomic ion, and you want to be getting that information from your polyatomic ion sheet. So we've identified the ions in the formula. The next step is name the positive ion first. Na is positive, Na+. So we're going to name this one first. It's called sodium. Then we're going to name the negative ion second. Chlorate. ClO3 is chlorate. Sodium chlorate. Okay, and then we're done. We do not have to change any suffixes at all. When it is given to you as a negative polyatomic ion, the suffix is already changed for you. You don't have to change anything. Just name the positive ion and then name the negative ion. Let's work on our second one. Mg, we see it right here. It's called magnesium. CO3 we can find right here. CO3 is called carbonate. Our final answer is magnesium carbonate. Again, when you have a negative ion that is polyatomic, you do not have to change the suffix. You only have to change the suffix if it is a negative ion that is not polyatomic. Example would be something like oxygen. Oxygen symbol is O. That would become oxide. This needs to be changed. This one doesn't need to be changed. Let's move on to our final question. NH4 2Cr2O7. What we have here is we have two polyatomic ions. We have a positive polyatomic ion and we have a negative polyatomic ion. Again, you just name the positive ion first. Ammonium. And then you name the negative ion second. Dichromate. And you're done. Ammonium dichromate. Let's take a look at two more problems. We have Cu2SO4. So we find Cu, or copper, on our periodic table. But we notice something. Cu has two different ions. It is a multivalent element. So we have to figure out which ion is being used. Is it the 1+ ion or is it the 2+ ion? But we have identified it. Now we're going to identify SO4. SO4 is called sulfate. Sulfate has a charge of 2-. Cu has a charge that could be either 2+ or 1+. So if you remember from last time, what we can do is we can go SO4 2-, and we know that has a charge of -2. We have two coppers. Our total charge is 0. What we need our coppers to be is have a total charge of +2. That'll make the charge 0. If we use this ion right here, the 2+ ion, this will be 2+, 2+, and this will be 4+. But if we use this one, then what we'll see is that it'll equal +2, and our total charge will be 0. So this is the ion that is being used. So we're going to write that in. Again, name the positive ion first. Copper. Identify which ion is being used. We're using the 1+ ion. So I'm going to write brackets, and in Roman numerals, I'm going to write 1. Copper 1, and then I'm going to write this polyatomic ion, sulfate. Copper 1 sulfate. I'm then going to do this next question, AgSO3. I find Ag on my periodic table, and we see that it is silver. Silver only has one ion, so I do not have to worry about writing a Roman numeral. Silver. Now what we see here is that this is sulfite. SO3 is called sulfite, silver sulfite. Now, what I've noticed here is there is a small mistake with this problem right here. This charge isn't balanced. What it should be is Ag2SO3. Because the total charge should be 0, and this only has a +1, and this has a 2-. So there's a mistake with this question. Should be Ag2SO3. Now let's look at writing the formula for something that contains a polyatomic ion. Again, identify the ion charge is the first step. Determine the ion charge is the second step. And use brackets around the polyatomic ion if there's a subscript number. So let's take a look at this one right here. Sodium. So we can identify sodium on our periodic table as Na. So what I'm going to do is I'm going to write Na. We can see that sodium only has one ion, which is plus. And then we're going to do sulfite. We can find sulfite right down here. Sulfite. We can use our cross method just like before, where this number comes down right there, and this number comes down and goes right there. Since this is 1, we don't have to write it, and this is 2, so we're going to write a 2 right there. So our final answer is Na2 SO3, sodium sulfite. Now we see this next problem is iron 3 phosphate. We know that iron is multivalent because it wrote in brackets 3 right here, and we can see that on our periodic table. We know that this is the ion that is being used. So we're going to write Fe 3 plus and phosphate PO4 3 minus. I then write it together. Fe PO4. We then take these numbers and we do our cross method. And we can write our numbers here, 3 and 3. So it could be something like Fe3, and we're going to put a bracket right here, PO4 3. We put a bracket so it doesn't look like it's 43. We also don't want to look like it's oxygen 43. We want to signify that PO4 is 3. But we notice something, 3 and 3. There's a common denominator. We can divide by 3. And that makes our answer Fe PO4. And we can get rid of our brackets because there's only a 1 right here, and we don't bother writing 1s. Let's do our next question right here. Ammonium phosphate. Ammonium is right here, and we know that the symbol for ammonium is NH4+. And phosphate is right here. We then write it together. And we use our cross method again. It then becomes NH4 and a 3 right here, and this is a 1. But we don't really usually write 1s. So we write this again, NH4. There's 3 of them, but I don't want to write a 3 right here because it looks like it says 43. It also makes it look like that it says H43. And what I want to say is there are 3 NH4s. So I put a bracket around here, and then I write my 3. And then I write PO4. There's only one PO4, so I don't need to bother writing brackets around it. It's just NH4 3 PO4. And again, this is my final answer.